Hey everyone, in this video we're gonna learn how to read the graph and how to determine the intervals when the graph is increasing, then decreasing, then constant, and also we can determine the relative minimum. Alright, so let's get into it. So first of all, what does mean the graph is increasing? Too simply, it means the graph is going upward from left to right. So we can see this pattern here on the graph going upward in here. And then how we find the interval that the graph is increasing. And that we're gonna use the shadow method again, and we are interested only on the x values, which means we are projecting the shadow only vertically. So this is how you project the shadow. Now pay extra attention to this arrow, since it means that the graph is gonna extend all the way up. Right? So it means as well that the shadow is gonna be keep going, right? So what is the part that is gonna be shaded on the x-axis? And that part is starting from 1 here, all right, and you're going to be shaded all the way to infinity. So make sure it's going to be extended, right? So now the part starts from 1 and goes all the way to infinity. So whenever you're going to write the interval, you're going to write 1 comma infinity, always starting with the smallest number, which is 1. And then you are supposed to deliver your interval in an open format. So never close it. So it's open here and open here. So that the open interval 1 plus infinity. Similar way we're gonna do as well for decreasing. So the meaning of decreasing, it means the graph is going downward, and we can see it here on this other graph. Is starting from here, going all the way here. Whenever we project it vertically, this you're gonna cast the shadow on the axis from here to there, and this is the part only that interests us for now, right? That part is extending from -1, this part here, all the way to 1. So you can write your interval as -1 comma 1, and again we deliver the interval as open format. All right, now for constant, again constant means horizontal. All right, there is no change on the value of the y's, neither upward neither downward. So we return to the first part of the graph, and we can see that part is only reflected here. And if we cast the shadow, you're gonna start from -4 all the way to -1. And again, we look for the shadow on the x, and that's will be the interval starting from -4 and ends at -1, sorry. So I can write it down as -4 open comma -1 and open as well. Now we are looking for the relative minimum, right? So here there is kind of two variations. If I'm looking for the minimum of a function, would be obviously right here, right? So this is a minimum where it's gonna happen, and it's happening at -2 there and 1 here. So it can be 1 for the x, -2 for the y's. So the minimum of the function is always the lowest point. What does mean lowest point? It means the lowest point on the y's, right? So the minimum function is -2. That should be the answer. And if they are asking for the location, probably they are looking for the location of the point. So the location of the relative minimum is this one here, right? So they are not asking about the minimum of the function, right? So the location is the point, this one, 1 -2. So you can answer as 1 comma -2, and this is not an interval, this is a point, right? So is the point 1 minus 2, and that's all.